We'll start from vectors. So we said like vectors are two components. The components are rather two properties. The properties are the magnitude of a vector and the direction of a vector. Okay, right? And we represented vectors using a notation like this. So a vector was represented by using a line, and we said the length of the line AB denotes the magnitude of the vector AB, and the direction of the line AB denotes the direction of the vector AB. Okay, right. So apart from that, we discussed about the addition of vectors. So if we have 3 points A, B, C, we have 3 points A, B and C, and it was given that the vector AB is simple A, the vector BC is simple B, and we are supposed to find the vector AC. How do we do that? So we write AC equals to AB plus BC. So the vector AB is simple A and the vector BC is simple B. We are good with this, right? Fine. And then we discussed about the reverse vector, which means if we write PQ as simple P, if we consider the vector PQ as simple P, then we can say the reverse of PQ is QP, and what should be the vector QP? If this is simple P, the reverse is, what should the reverse? That is the minus P. That is going to be minus P, right? So in addition of vectors, if we have something like this, so they have given this is OAB, and this is A and this is B. So if they ask us to find the vector AB, I can write AB equals to AO plus OB. So here AO is minus A. This is minus A plus B. Are you okay with that? Right? And thereafter we studied about the equal vectors. So what are equal vectors? Rather, what are the conditions you should satisfy for any two vectors to be equal to each other? For example, we have a square PQRS, and this is given as simple A and this is given as simple B. So what are the conditions for two vectors to be equal to each other? They should be parallel, rather equal in direction and equal in magnitude. So what should be the equal vector of PQ? SR, the equal vector is SR, and here the equal vector is QR. Fine, right? Right. So we'll do a few more questions on this and then move on to today's section. Right. So we'll start from this one. Here they have given us a hexagon. So the vector, the points are A, B, C, D, E and F, and the vectors are given as simple A, and this is B, and this is B, and this is said as C, and this is C. Here we are supposed to find the vector BF, the vector CF, and then the vector AD, and the vector EB. Okay, so start from this one. Right, so we'll start the question 1 first, and thereafter we can move on to the question 2. So in question 2 they have given us to find, we are supposed to find the vector OB and the vector OC, the vector AC, DA and finally OD. Right, so if we start from BF here, the vector BF is equals to BA plus AF. So BA is minus A plus C and the vector CF. So CF can be written as CF equals to CB plus BA and AF. So CB is minus B minus A plus C, minus B minus A and plus C. And we have the vector AD. The vector AD. So AD is equals to AF plus FE plus ED. So AF is simple C and B plus A. And finally, we are supposed to find the vector EB. So EB equals to, the vector EB is equals to EF plus FA, EF, FA and AB. Right. So EF is minus B minus C plus E. Just check whether the answers are correct. Okay. So if we move on to the next, here we have OB. So we'll write the vectors here. OB. So we can write OB equals to OA plus AB. So OA is simple A and AB is 5B. Simple A plus 5B. Right. And next OC. You can write OC equals to I can directly use OB here. So it's OB plus BC. OB plus BC. OB is A plus 5B and BC is the opposite of 4A, which is minus 4A. So this should be equals to 5B minus 3. Just check whether the answers are correct. Right, so here we have OB, which is A plus 5B and OC, which is 5B minus 3A. Right. So continue with the others. We have AC, DA and OD. Right. So AC is something around here. So AC equals to, we can write AC is equals to AB plus BC. So the vector AB is 5B and the vector BC is minus 4A. And DA. So DA equals to DC plus CB plus BA. DC means 2B and CB is 4A and this is minus 5B. So which is equals to 4A minus 3B. 4A minus 3B. Right? And next, so we have DA and AC and finally OD. So I can write OD equals to, now since I have found DA, I will write it from the beginning. OD is OA plus AB plus BC CD. So OA is simple A and this is 5B minus 4A minus 2B. When you simplify this, we get minus 3A plus 2B. Minus 3A plus 3B. Is that the answer for OD? Minus 3B. Right. So I hope you are fine with this. This is where we stopped last week. Okay. Right. So the ones who are not finished, just copy it down. Fine, right? Okay, we'll write the next topic. Write the next topic in vectors. Dividing a vector. Dividing a vector to a given ratio. Dividing a vector to a given ratio. Dividing a vector to a given ratio. Okay, so what happens here is, now we have already discussed the addition of vectors. We know this theorem and we have done quite a lot of sum using this theory, the addition of vectors. And now we are going to learn the second part of vectors, which is called this division part. So once you are done with this, so we have done the first part already and we are going to do second part now. So once we are done with this, we are completely fine by what do you call? So we know all the methods of writing the vectors of any given line. So we'll start from here. Now think we have a line AB and they have said the length of the line AB is 12 centimeters. So in other words, they have given the length of the line AB is 12 centimeters and we have a point C on AB and the ratio is 3:1. Okay, and I'm supposed to find the length of AC. How do we find the length of AC? Did you get the question? So the total length AB is 12 and the point C divides AB to the ratio 3:1 and I'm supposed to find AC. What is the length of AC? 3 divided by 4. So he says AC is equals to 3 divided by 4. Is that correct? Now we go to a shop, cake shop, okay? And they say this cake has 8 pieces and it is 800 rupees. And I need 3 of them. What is the price of 3 of them? We have a cake. The total price of the cake is 800 and they have separated that, they have cut it into 8 equal pieces. Okay, they have cut it into equal pieces and I want 3 of them. 3 over 8. Oh, no, don't tell 300. I need the method how you found the answer. Okay, we'll do this. Okay. No, just tell me the method how you got the answer. Okay, so what you do is, like, we have altogether we have 8 pieces and from 8 pieces how much are we going to buy? 3, right? And what are we going to do? We should multiply this by the total price, right? So here also the length of the line AC is not 3 over 4. What should I do? Then multiply it by the total length. Do you get that? So this is called the ratio. This is the ratio of what we have selected from the total cake and this is the price of the total cake. So when you multiply the selected by the total price, you can get the price of the selected cake. Fine, right? Similarly, here the length of the line AB is 12 and the ratio what I have selected is 3 over 4 and I should multiply it by the total length. So then we can tell, right, the length of the line AC is 9 centimeters. Are you okay with that? So initially you should find the ratio and then the total length. Fine, right? So the same thing happens in vectors. It's very similar to the length of the line in vectors. We'll consider a vector AB, right? So we have a vector AB running from point A to point B, which is called simple A. And we have a point C on AB. We have a point C on AB and they have given the ratio is again 3:1. Now I am supposed to find the vector AC. I am supposed to find the vector AC. So what is the vector AC? Initially, what should be the ratio of AC? It is 3 over 4, right? This is 3 over 4. And what must be the complete vector that represents AC? The complete vector, it's AB. Fine, right? It's AB. Now, what goes different from length and vectors is this. If I am supposed to find BC, what is the ratio of BC? The ratio of BC is 1 over 4. What is the complete vector representing BC? Is it AB or BA? So I am talking about the vector BC. So then the complete vector should be BA, right? Because BC, the vector in direction of BC is BA, not AB. So here we write BA. Do you get that? Now when finding the length, we don't mind that, because from here to here also it's 12, and from here to here it's also 12. But when it comes to vectors, I write BA equals to 1/4 BC equals to 1/4 BA. So then we can write AC equals to 3 over 4. The vector AB is simple A, fine. And then what should be the answer here? Vector BA means it is the opposite of AB, which is minus A. So here we can write BC equals to 1 over 4 minus A. So it's minus 1 over 4A. Are we okay with this? So what you have to find is, initially you should think about the ratio and then about the vector. Write the ratio properly and then select the complete vector, and its direction should be equal to AC, and then write the complete vector. Fine, right? Okay, we'll start from here. So the ones who joined late, just write the topic. Dividing a vector to a given ratio. Dividing a vector to a given ratio, and we'll write this. AB is simple A, and we are supposed to find AC and BC. Right. So finish this, and thereafter I'll write few examples. Just try this out. Write this first, and then question 2 is, here we have 3 points P, Q, R. P, Q and R. The ratio here is 2 to 3, and the vector is simple P. You are supposed to find the vector PQ, RQ and QP. Find these three vectors. Okay, so the problem in vectors is this: we can write this like this as 3a over 4. But the problem is, like, we have these two horizontal lines. No? So what we do is, we don't write it like this. This is not wrong. We don't divide a vector by a number. Instead, we write it as a coefficient, because these two lines can be mixed up. Okay? Right. Okay. So the ones who finished this, just try this also. We have the vector, the 3 points PQR. We have the 3 points PQR, and the vector PR is simple P. The vector PR is simple P. We are supposed to find the vector PQ, RQ and QP. Right, so here we can write PQ. So the vector PQ is a portion of PR and the ratio is 2 over 5. So it's 2 over 5 PR. So PR is equal to simple P, which is 2 over 5 simple P. Right. And RQ. So RQ, the ratio of RQ is 3 over 5 and the complete vector of RQ is RP, which is equals to minus P. So the final answer should be minus 3 over 5P. The final answer is minus 3 over 5P. And here QP, so we can write QP equals to 2 over 5 RP, 2 over 5 RP. So the vector RP is minus P, which is equals to minus 2 over 5 P. Just see whether the answers are correct. Right, so here the vector NM is equals to 3 divided by 7, the ratio is 3 over 7 and the complete vector is PM. So PM is simple B, it's 3 over 7 simple B. And PN, so PN the ratio is 4 over 7 and this is PM and the vector is 4 over 7 B. So when you move on to Mn, the ratio is 3 over 7 and the complete vector must be MP. The complete vector must be MP. So the MP is the opposite of PM, which is minus B. So minus 3 over 7B. Minus 3 over 7B. Right. We'll try this out also. Question 4. So the ones who are finished with the fourth question can try the question 5. Right, so here we can write the vector AC. So AC, the ratio of AC is 3 over 10 AE. The vector AE is simple A. So 3 over 10 simple A. And EC, the vector EC, the ratio is 7 over 10 EA. EA is minus A. So minus 7 over 10 A. Right. We'll try this out also. Question 5. Right, so here AB, so I can write AB, the ratio of the vector AB is 4 over 9 AD. The vector AD is simple A, so it is 4 over 9 simple A. And CB, the vector CB is 3 over 9 CB, so the complete vector of CB is DA. It is DA, DA is minus A, so this is minus 3 over 9 times A. And we move on to CD, so the vector CD equals to, here this is 2 over 9, so CD is, the complete vector of CD is AD, which is simple A, 2 over 9 simple A. Are we okay with that? Okay. Okay, so we can simplify this. This can be written as minus 1 over 3. Okay. This should be plus AD. Yeah, this should be plus. Okay. Right. So CD should be positive. CD should be positive. And then BD, the vector BD. So we can write BD. So the ratio of the line BD is equals to, this is 3 and 2, which is 5, and the complete ratio is 9. 5 over 9 AD. So AD is simple A, 5 over 9 simple A. Yeah. Yeah, you can write this as minus 1 over 3 simple A. Okay? Right. So BD is written, and then CA, the vector CA, the ratio of the vector CA is 7 over 9, and the complete vector is DA. So DA is minus A, which is minus 7 over 9 times A. Okay, right? Right. So we are good with this. Next we'll write the topic, finding the vector of the line joining 2 points. Finding the vector of the line joining 2 points. Okay? Right. So this is the thing. Now, always keep in mind, you have two methods of writing the vectors. One is, if the vector you are finding, if the vector that you are supposed to find is a complete vector. So what I means by a complete vector is this. Now see, this is AB and this is C, A and B. And we have another example. The line AB and C is on AB in the ratio 3 to 1, which is simple A. Okay? Right. So what I meant by a complete vector is this. In this example, AB is a complete vector, and in this example, is AC a complete vector? What do you think? In this example, AB is a complete vector. In this example, is AC a complete vector? No, AC is not a complete vector. AC is a portion of AB. Do you get that? But here AB is a complete vector. Are you okay with that? Now I draw another example. Here we have a triangle, and this is OAB, and this is C. I'm speaking about the vector AC. Is AC a complete vector or a portion of a complete vector? It's a portion of a complete vector. What about OC? Is OC a complete vector or a portion of a vector? Is OC a complete vector or a portion of a complete vector? Anyone who's saying that's a portion of a vector? Now you might get an idea like this, because C is in the mid of A and B. Is OC a portion? No, OC is not a portion now. C is a midpoint of A and B. That's correct. But the vector OC is a complete vector. Do you get that? Right. So here I'm starting from the beginning. AB is a complete vector, AC is a portion of a vector, and here AC is a portion of a vector and OC is a complete vector. So there is this. If you are supposed to find a complete vector, use the method of vector addition. So you can write directly AB is equals to AC plus CB. Do you get that? And if you are supposed to find a portion of a complete vector, then we use the method of the ratio theorem. Are you okay with that? If you are finding a complete vector, use the theory of vector addition. If you are finding a portion of a vector, then you should use the ratio method. Are we good with that? Okay, just write below that. Use the following steps. Use the following two steps. Rather, two methods. Use the following two methods. Use the following two methods when finding its vectors. Use the following two methods when finding the vector of the line. The vector of a line joining 2 points, the vector of a line joining 2 points, right? So we do that, right? The part 1. If the vector is a complete vector, if the vector is a complete vector, use the method of addition of vectors. Use the method of the addition of vectors. And part 2, if the vector is a portion of a complete vector, if the vector is a portion of a complete vector, use the ratio method to find the vector. Use the ratio method to find the vector. Okay, right. So as I said before, like today we would be able to cover up all the theories, right? All the questions regarding to the addition of vectors. So we have few more theories. So like the hardest question we had in past papers regarding to addition of vectors is 2013. So 2013 LL question is mainly based on addition of vectors, and there were no more theories that were questioned in this year. So today we would be, in the previous classes also we tried this, so today our plan is to finish all the theories and then come to this point. Okay, right, we'll start from here. We have a triangle OAB, right? So they have given us the point, this is O, A and B, and the vector of OA is simple A and the vector of OB is simple B, right? And they say there is a point on C in the ratio 3:1. C is a point on AB in the ratio 3:1, and I am supposed to find OC. Right, we'll start. So initially, OC, is OC a complete vector or a portion of a complete vector? It's a complete vector, so I can write OC either OA plus ACO, OB plus BC. Fine, right? I can use both the methods. We'll start from A. So OC is equals to OA plus AC, right? So after writing this, you should simplify these separately. I mean, don't write AC in a separate space and find it. Just find it here itself, but think of them separately. Think of each vector separately. So when you are finding OA, don't think of AC, and when you are finding AC, don't think of OA. We'll do them separately, right? So what is OA now? What is the vector OA? It is simple A, right? So done. Vector A, OA is simple A. That is finished. AC, is AC a complete vector or a portion? It's a portion of a vector. What's the complete of AC? AB. The complete vector of AC is AB, and what's the ratio? 3/4. So I can write AC is a portion and its complete vector is AB. Alright, so are we good up to this point? Fine. Now we are supposed to find AB again. A plus 3/4, right? AB, is AB a complete vector or a portion? It's a complete vector, so I can write the addition method. AB is equals to AO plus OB. Fine, right? So AB is equals to AO plus OB, right? So this is simple A plus 3/4. The vector AO is minus A and the vector OB is plus B. Are we good up to this point? Right. So from this point onwards, you must simplify this. So after this point, if it's hard for you, just leave it as it is. You don't need to simplify it, because we are now studying only vectors, not the simplification part. But better if you can simplify this. So there are two methods you can simplify this. One is, now here the denominator is 4. So to take a common denominator with this A, we can write 4A divided by 4. Fine. And this is 3/4 minus A plus B. Now both these terms has a denominator of 4. What we do is we consider 1 over 4 as a common factor and write 4a plus 3 times minus a plus b. Just understand what I did there. Are you all okay with that? What we did was we had denominator of 4 here, multiplied this by 4 and divided this by 4. So both these terms had a denominator of 4, considered 1 over 4 as a common factor, the remaining is 4a and 3 times minus a plus b. And when you simplify this, you would get 4a, and this is 4a minus 3a plus 3b. So you can write it as 4a. 4a minus 3a is a plus 3b, so the final answer is 1/4 a plus 3b. Okay, so like if you are finding it difficult to simplify from this point onwards, that's fine, leave it as it is. But if you are okay with this, you can continue. Fine, right? So what I want you is to finish at this, the vector addition part. Fine, right? Right, just copy this down. So if you write this using b, you should get the same answer. Like this would be different. When you simplify, it's the same answer. Okay. So if you use if you write OB plus BC, there also you get the same answer. Fine. Okay. So if you are finished with that, we'll like start from very easy questions. Right. We'll start from this. So this is our question 1. So if you all have any question, if you have any doubts, just ask it. Now this is a square. So in this square they have given, these are the 4 points for vertices A, B, C and D. The vector AB is simple A and the vector AD is simple B. The midpoint of BC is E and we have a point here F which is in the ratio 3:1 and this is 1:1. And you are supposed to find the vector AE and AF, BF and DE and finally FE. Okay, so start it from there. Right, so we'll start with this, and since most of you have finished it, I'll write the second example here and thereafter we'll move on to this. Right, so here the question 2. We have parallelogram PQRS. This is P, Q, R and S. So here the vector PQ is simple A and this is given as simple B. Make sure you write the equal vectors. So the ones who joined today, I will explain it later. And here we have a point A which is in the ratio 1:4 and a point B which is in the ratio 3:2. And you are supposed to find PB and AP, PB, AP and AS and QB and finally AB. So write this down. Right, so I hope you remember this. We discussed this last week. So when you have equal vectors, so the newcomers, what we do is when we have equal vectors, now here the vector DC is equals to AB. So what you should do is you should write this as A. Before starting the question, mark all the equal vectors. Fine, right? And thereafter you can start simplifying. Okay, so the vector AE. So I can write AE equals to now AE is a complete vector. A is a complete vector, so we write it as AB plus BE. Fine, right? Okay, so it is AB plus BE. So the vector AB is simple A and the vector BE is half of BC. So this can be written as A plus half, BC is simple B. A plus half, simple B. Fine, right? Okay. We'll move on to AF now. So AF is a complete vector. So we can write AF equals to AD plus DF. So AD is simple B and DF is a portion. The complete vector of DF is DC and the ratio is 1 over 4. It's 1 over 4 DC. So we can write B plus 1 over 4 simple A. Are we okay with that? Right. And next we'll start from BF. So the easiest way to move from B to F is via C. So we can write BF equals to BC plus CF. So BC is minus B, rather plus B, and CF is a portion which is 3 over 4. 3 over 4 CD. So here the vector DC is A, so CD means minus A. So this should be B minus 3 over 4 A. Right. So just continue with that. If you are finished with that, start the question 2. If you have any doubts on this, just ask. Right, so BF is done here, then DF. So DF is equals to, rather DE. DE is equals to DC plus CE. So DC is simple A and C is 1 half CB. So CB is minus B, A minus half B. FE. So FE equals to FC plus CE. FC is a portion, so it's 3 divided by 4. 3 over 4 DC. And CE is a portion of CB, which is half CB. So we can write this as 3 over 4. DC is simple A and half of CB is equals to minus B. So here the final answer is 3 over 4A minus half B. 3 over 4A minus half B. Are those answers correct? Just check your answers. Fine. Right. So I'll write the third example here. Right, so here you are supposed to find the vector AF and the vector AE and the vector AP, which is quite complex, and then the vector CP and the vector DP. Right, just start that. Right, so we'll move on to here. Here, first of all, you should write the equal vectors. So this is equals to B and this is equals to A. Right. So we can write PB. So PB means PS plus SB. PB is equals to PS plus SB. So PS is simple B and SB is 2 over 5 SR, which is equals to simple A. And AP. So AP is equals to AQ plus QP. So AQ is a portion of RQ. The ratio is 1 over 5 RQ plus QP is a reverse of a PQ, which is minus A. So this should be minus 1 over 5 B minus A. Minus 1 over 5 B minus A. Right, so the next is AS. So we are supposed to find the vector AS. Right, so we can write AS equals to AR plus RS. So AR is 4 over 5 QR. QR, yes, 4 over 5 QR. And RS is the opposite of SR, which is minus A. So we can write this as 4 over 5 simple B minus A. 4 over 5 simple B minus A. Next, QB, the vector QB. So QB equals to QR plus RB. QB equals to QR plus RB. QR is simple B and RB is 3 over 2, rather 3 over 5 RS. So this is simple B and RS is minus A. B minus 3 over 5A. That is QB. And next, finally, you are supposed to find AB here. So we'll just remove this. Right, so AB. So here AB can be written as AB equals to AR plus RB. So AR is 4 over 5 QR plus RB is 3 over 5 RS. This is 4 over 5. QR is simple B plus 3 over 5. RS is minus A. So final answer would be 4 over 5B minus 3 over 5A. 4 over 5B minus 3 over 5A. Okay, so that's the end of the question 2. Just see the answers are correct. Now question 3, when you deal with the point P, you have few stuff to understand there, because point P is the mid of E and F and it's quite hard. Okay, so we'll start the question 3. Okay, so here to find AF, like we'll do a much easy example. So the method of writing AF is something like this, AP. So either you can use this route to go from A to P or else through D. So we can write AP equals to AB plus BE plus EP. So that's what we did now. Okay, AP is equals to AB, BE and EP. So now we know AB. AB is simple A, fine. AB is simple A. What about BE? BE is a portion of BC. So BE is a portion of BC. This is 1 to 1, which means it's half of BC. So you can write half BC, that's also fine. What about EP? EP is a portion of EF. Fine, right? Now EP is a portion of EF, so the ratio is 1 to 2. I can write EP as 1/3 EF. Are you okay with that? Fine. So now how to find EF? Again, you can now, EF is a complete vector. You can write it as EC plus CF. Did you get that? Now EP is a portion of EF. So I can write EP as 1/3 EF. Now EF is a complete vector. You can write EF equals to EC plus CF. Then thereafter you should again find EC and CF. Fine. Okay, just leave that question aside. We'll move on to a simpler one and then we'll come back there again. And that's a quite hard in that question. Right, we'll start from this. So leave the question 3 aside. Question 4. So we have a triangle. We have a triangle and this is PQR, OPQ and this is R. This is 4 to 1 and the vector OP is simple A and this is simple B. Initially you are supposed to find QR. You are supposed to find QR and then OR. Right, we'll start from this one. Find QR and OR. Right. Leave the question 3 aside. We'll move on with question 4. Okay, so we'll start with the question 4. So there we are supposed to find QR. So we don't have any equal vectors here. So I can write QR, right? So QR is a portion of QP. So we can write QR equals to, this is 1, this is 4, it's 1 over 5. 1 over 5 QP. Right. So it's 1 over 5. QP can be written as QO plus OP. QO plus OP. So this is 1 over 5. QO is minus B. Minus B plus A. It's 1 over 5 minus B plus A. Okay, so next we should find OR. Next find OR. And simplify it if you are able to. If it's hard in simplify, just leave it as it, that's fine. But try to simplify. Okay, so question 4 is done. We'll move on to question 5. So we have another triangle here. And they have given this is ABC. This is simple A and this is simple B. And this is E and this is F. This is 3 to 1, 2 to 1. And you are supposed to find OF, BE and finally FE, rather EF. Okay. Just start with this also. Question 5. Okay. So I'll finish this question OR. So I can write OR equals to OP plus PR. OP plus PR. So OP is simple A, it's a complete vector, and PR is a portion, so I can write it as a ratio 4 over 5 PQ. So this is simple A plus 4 over 5. PQ is equals to PO plus OQ. PO plus OQ. Right. So this is simple A plus 4 over 5. PO means minus A plus OQ is plus B. Right. This should be AF, sorry, not OF, AF. Right, AF. Okay, right. So if you simplify this, we can write this as 5A divided by 5, 4 over 5 minus A plus B. Now consider 1 over 5 as a common factor. So the remaining here would be 5A and this is minus 4A plus 4B. And when you simplify this, you get 1 over 5 A plus 4B. 1 over 5 A plus 4B. Is that answer correct for OR? 1 over 5 A plus 4B. Okay, right. So we'll move on to question 5. So if you all have any questions, just ask. Don't have doubts and continue. Right, so we'll start with question 5. So the ones who have finished with that, you can start this. This is question 5 and this is question 6. So in question 6 you are given, this is a parallelogram. So the entire vector OA is simple A and this is simple C. And this is in the ratio 2 to 1. And this is D. This is 1 to 1. You are supposed to find, this is E. You are supposed to find the vector CE and the vector BE, the vector OD and AD. Right, so we'll start from here. So AF equals to AB plus BF. So AB is simple A and BF is 1/3 BC. This is simple A and BC. So BC is a complete vector. You can write it as BA plus AC. So it should be BA plus AC. So this is equals to A plus 1/3. BA means minus A. AC is simple B. So thereafter what you have to do is find the common denominator of this. So this is 3 over 3A plus 1 over 3 minus A plus B. So 1 over 3, this is 3A minus A plus B. 1/3 2A plus B. 1/3 2A plus B. Just check whether the answer of A, F. Yeah. So it's 1/3 2A plus B. Right. So we'll start with BF, BE also. So BE is quite easier. Right, so the next is BF. So we'll write BF. BF is equals to BA plus AF. BF is equals to BA plus AF. So BA is minus A and AF is A, that is BF. It's BE. Right, AE is a portion of AC, which is 304 AC. So we can write it as simple minus say 304B. And then finally EF. Now when finding EF, you can use this. I have already erased EF. Rather AF. Now we found AF. AF, what is the answer we got for AF? It's 1 over 3 2A plus B. What's the answer for AF? Okay? So since we have already found AF, I can easily write EF is equals to EA plus AF, right? Instead of writing EC plus CF, I can easily write EF equals to EA plus AF. Okay? So then EF equals to EA plus AF. So EA means 3 over 4. 3 over 4 CA and AF is 1/3 2A plus B. Okay? Right. So when you simplify this, so you can write CA is minus B. So this is minus 3 over 4B plus 1 over 3 2A plus B. Now simplifying this. So if you are fine with this, you can just simplify. So when simplifying this is what you should do. Right. So here what you should do is, like, we can consider the common denominator of this. You can multiply this by 3. So this is 3 into 3 divided by 4 into 3 B, and multiply this by 4. 4 over 12 and 2A plus B. Are we okay with that? So what we did was we multiplied this by 3 and this by 4. So this is, then 3 times 3 is 9 over 12 and this is 4 over 12. So I can consider 1 over 12 as a common factor. So 1 over 12 as the common factor. What would be remaining here is minus 9b. Minus 9b, and this is plus 8a, 8a and 4b. So the final answer would be 1 over 12, 8a minus 5b. Is that the answer you get for BE? Okay, right. Not BE, that is EF, right? EF. So that is EF. Right, so we are good with question 5, then question 6. So the ones who have finished question 6 can start the past paper question. So the question is this. Right, so I will be moving on with question 6. The ones who have finished question 6, start this. Now they say OABC is a parallelogram, rather it's a quadrilateral. So you don't have any parallel sides here. This is OABC, OA, B and C. And they have given the diagonals OB and OC. The midpoint of, we'll consider O. Right. So this is AC, okay? The midpoint of OB, the midpoint of OB is D, so it's a midpoint, okay? And the midpoint of AC is E, and the midpoint of DE is F. Are you okay with that? So what they say, the midpoint of OB is D, the midpoint of AC is E, and the midpoint of DE is F. Fine, right? You are supposed to find the vector AF, and you are provided with this. The vector OA is simple A, this is simple B, and this is simple C. And they are asking us to show that OF equals to 1 over 4 A plus B plus C. This is the answer you should get for OF. Okay, shall we try it out? So once we finish this first. So this is 2013 A-levels essay question, not a structured one. So you have a bit of work to do here. Start doing that. 2013 A-levels. Right, we'll start from this. So initially finding CF. So we can write CF. What's CF? CF is quite easier. Before that you should mark all the equal vectors. So this is simple A and this is simple C. So CF is equals to CO plus OE. CO is minus C plus OE is 2 over 3 simple A, right? And then you are supposed to find BE. So BE equals to BA plus AE. BA is minus C minus 1 over 3A and OD. AD. Right, we'll write OD. So the vector OD is equals to OE plus ED. So OE is 2 over 3 OA. ED is half EC. This is 2 over 3 simple A plus half. EC is, so EC is a complete vector. You can write it as EO plus OC. So here this is 2 over 3A plus half EO. So EO is a portion of AO and the ratio of it is 2 over 3. I can directly write it as 2 over 3A and OC is simple C. Now simplify this, you would be getting the answer for OD. Right, so when you multiply this by half, that would be much easier. So this is 2 over 3A minus 1 over 3A plus half C. So the answer would be 1 over 3 A plus half C. Is that the answer you got for OD? Yes. E is the midpoint of, this is the midpoint of AC, D is the midpoint of OB, and F is the midpoint of DE. Okay, so all these are midpoints and the ratios are 1 to 1. Here also it's a midpoint ratio is 1 to 1. The ones who finished this, is this correct? The vector OD is OD half C and 1 over 3A. Okay, and we'll finish AD also. Yeah. So you can have a common denominator and write it as 1 over 6 2A plus 3C. Right, that is correct. And since I have found AD, we can write OD. We can easily write AD as AO plus OD. So AO is minus A plus OD is 1 over 6 2A plus 3C. 1 over 6, when you multiply this by 6, we get minus 6A. So minus 4A plus 3C. Is that the answer you get for AD? Okay, so we'll start this question. We are supposed to find OF here. So we can start it. So what is the easiest way to reach F from the point O? It's OD plus DF, right? So we can write OD plus DF and then start writing OD separately and DF separately. Okay, start with that one. So you can write OF equals to OD plus DF, and OD is half OB. OD is half of OB. Yep. All right. So we'll start it from here. You can write it as OF equals to OD plus OF equals to OD plus DF. Right. So OD is half of OB, and you can write DE as half, rather DF as half of DE. DF as half of DE, and thereafter consider both those half as common factors and write it as half into OB plus DE. Okay, so we can write OD as half OB, DF as half DE, and write DE as DOOA and AE. DOOA and AE. Okay. So here OD can be written as OD is half OB, and DF can be written as half of DE, half of DE. Right, consider plus half as a common factor. So here what's remaining would be OB and DE. Right, now substitute the values. So OB is simple B. You can write DE as DE can be written as DO, OA and AE, right? Okay, just start from there. So this is quite complex, it's not that easy. Finished. Okay, there are ones who have finished. The ones who have finished can start this. And furthermore, they have given there is a midpoint on AB called P. You are supposed to find PF. There's a midpoint on AB called P, and you are supposed to find PF. So the ones who are not finished, just right up to this point, OF equals to half into OB plus DE, and you can write OB as simple B. DE, write DE as, use three vectors. DE equals to DO, OA and AE. Okay, so we'll start from here. So OB is simple B, OB is easy. So this is half. OB is simple B. Now I can write DE as DO plus OA AE. Fine, right? So what I did was, now OD is half of OB, which is half B. DF means half of DE. So DE can be written as DO, OA and AE. Okay, right? So DE is DO, OA, AE. Now DO, what is DO? DO is a portion. What is the complete vector of DO? DO is a portion of BO. So we can write it as half BO. So this is half into B plus half BO. So OA of course we know OA is simple A, and AE. AE is a portion of AC, it's half AC. Fine, right? So AE is equals to half AC. Right. Now simplify this. Half into B plus half. BO is minus B plus A plus half. AC, we can write AC as AO plus OC. So we'll write AC as AO plus OC. Right. This is half B minus half B, and this is A plus half minus A plus C. Right. So when you subtract this to B minus half B means it's again half of B, and this is A plus half minus A, which is minus half A plus half C. A minus half A is half of A, half B plus half A plus half of C. Now consider half as a common factor. 1 over 4 A plus B plus C. That's the answer. Okay, right? Are you all okay with what we discussed today? Except for this question, other questions are fine, right? All the 6 questions were okay, right?